Welcome to an Introduction to Chemistry, brought to you by Parkbench Tutors. For more information about Parkbench Tutors, look us up on Facebook, or you can find us at parkbenchtutors.com. In this little tutorial, we're going to continue our introduction to organic chemistry. So let's look at the next group, alkenes. You remember the first tutorial was on alkanes. So here's our simplest alkene, and you can see that what we've got is a double bond between the two carbons that form our chain. And this alkene is called ethene or ethene. If you have three carbons, you can see then we still can put a double bond in, but here it's between carbons 1 and 2, and this is known as propene. Now you might remember the corresponding alkanes to these were ethane and propane. So alkenes then have a double covalent bond between two adjacent carbon atoms. We can give them a general formula of CnH2n. So how do we name alkenes? Now here's a nice little example. You can see there are 5 carbon atoms, and the double bond is 3 carbon atoms away from one end, but it's only 2 carbon atoms away from the other end. So what are we going to do? Well, the system is to number them so that the lowest possible number is assigned to the double bond. And you can see it if we start counting in from the right hand side. This would be the second one, right? So the second carbon from the right. And so we call this, it's based on pentene because it's got 5 carbons, and we call it 2-pentene because that's where the double bond is going to occur. Okay, can we have anything more than double bonds? Yes, we can have triple bonds, and these are known as alkynes. And the general formula for these is CnH2n-2. It's a triple covalent bond between 2 adjacent carbons. And the simplest one, the simplest alkyne, is ethyne. The next one would be propyne. Here we are, there's our structure with our triple bond. And here we can show the orbitals. The bonds are formed by the p orbitals and one bond between the sp orbitals. How do we name the additions? Right, unsaturated compounds, whether they're alkenes or alkynes, they can add by breaking the double or triple bond. So here's an example. For example, we start with ethene with our double bond, we add bromine. This breaks our double bond and it puts a bromine, 2 bromines in fact, to give you 1,2-dibromoethane. Right, the name is based on ethane because that would be the corresponding alkane here, and there are no double bonds obviously in our product. So if we name it properly, we can see there's 1 bromine on each of those carbons, so it's 1,2-dibromoethane. Okay, let's continue this idea of naming. Here we are, we've chopped out the carbons here and just put in the bonds, but I think you can see what we're getting at. The double bonds then here are after the first carbon atom and the third carbon atom, right? And because they are double bonds, it's going to have an ENE. It'll be an ene compound. So it's got 1 on the first carbon, 1 double bond starts there, 1 double bond starts on the third carbon. So it's going to be 1,3-butadiene, right? The buta part shows that it would be based on the butane, butene, butine idea, and the diene shows that there are 2 double bonds, and the 1,3 part shows the position of those double bonds. There are some general names which actually aren't related to UPAC, which you might have heard of or come across. Aliphatic compounds are simply open chain hydrocarbons, and it doesn't matter whether they're straight or branched. Any carbon atoms that are arranged in a ring, a closed ring, form alicyclic compounds, and if they are unsaturated ring structures, they are often referred to as aromatics. So when we talk about aromatic chemistry, alicyclic chemistry and aliphatic chemistry in organics, that's what we mean. So the simplest of these cyclic ones, the alicyclic, would be just to have 3 carbons and join them together, and that would be cyclopropane. We could also join 5 and we could put a double bond in there, and we would have cyclopentene. The ene shows that double bond, the ene suffix. Okay, let's look at aromatics in a little more detail. These are the unsaturated ring structures. The basic formula is CnH2n-6. So the simplest of these is benzene, C6H6. Now, what shall we draw this? Here's one representation of benzene, one representation of the benzene ring. Whoops, I've flipped it. Here's another one. So, where are the double bonds? Well, actually the answer is we don't know. And so we consider these as being hybrid, and we consider that benzene shows resonance. In other words, the double bonds could flip back and forth between those structures. So when we write them or draw them, how do we go on? Well, we have to make the assumption that they are fixed. In other words, we say that they've got a particular orbital structure. We call them aromatics, by the way, because they often actually have a perfume or a smell. Right, so that's where that name comes from. Okay, let's look at the carbon skeleton idea. So here we've got the ring of 6 carbons, and we've just shown the positions of the double bonds as if they were fixed. Remember, this is just for convenience in writing out formula. So this is the benzene ring. So here's a nice simple benzene ring with something attached. How are we going to name it? We can see that it has a CH3 attached to it. So the first part is a C6H5 group, and that's a phenyl group. The common name for this particular substance is in fact toluene, but the name we would use is probably methylbenzene, because it's a methyl group attached to a benzene ring. Can you have more than one ring? Yes, it's possible to join 2 rings together, as we've shown here, and this would have a formula of C10H8, and this would be known as, or the common name for it is naphthalene. We can actually join 3 rings together as well. Here's an example, and that would be C14H10, and that would be called anthracene. So how will we use the UPAC system then? Well, the UPAC system looks at numbering the carbon atoms in a ring, and this is particularly important when we have isomers, because it depends, if you've got 2 groups being substituted in the ring, it depends on their position. We use the idea of ortho, meta and para. Let's see how this actually works. Okay, here is a benzene ring. We've attached 2 methyl groups and they're next to each other. So we call this 1,2-dimethylbenzene, or its common name is orthoxylene. Now let's look at another way of putting those methyl groups on. Here we put them on the first and third. So we call this 1,3-dimethylbenzene. Again, common name metaxylene. Or I could put them in this way, right? So this is on the first, 1 and 4, right? 2 methyl groups are 1 and 4. So this will be 1,4-dimethylbenzene, and its common name is paraxylene. So that's using isomers in organic chemistry with aromatics. Remember, we also met isomers with alkanes. One of the simplest ones you can have is butane. In fact, that's the simplest one, where we've got 4 carbons, and N-butane has a straight chain, but if we break it so that we set it up this way, we've got a methyl group essentially on a chain of 3, and we call this isobutane because it has a branched chain. We can get to from one to the other by a simple reaction of heating with aluminium chloride as a catalyst. Okay, that ends our first session, brought to you by Parkbench Tutors, narrated by David Hopcroft. For more information, look us up at parkbenchtutors.com or find us on Facebook. Thank you for watching and for listening. We wish you success in your studies.